All right. So thank you everyone for joining again on 2024. Um, we've been doing this since last March. So soon enough, it's going to be a year since we started doing these bi-weekly talks. Last year, I think the last talk we'd kind of asked to um, think about topics that you might want to see more this year that we want to focus on. And um, so far, what we've noticed, doing a little bit of um, how do you call it, going back and looking at stats, we've noticed that a lot of things that has to do with like AI and anything related to that have been kind of popular. So, but we want to kind of confirm the data points before we start focusing more on the AI side of things. But again, like I said, we definitely welcome any suggestions on what you want us to focus on this year, as well as we've always kind of said, is if you want to also present, to definitely raise your hand. We will kind of help you um, craft the how the format and also when how much time you need and all that stuff. So you can present for the whole time or an hour or 20 minutes. It doesn't matter, right? And usually the one benefit that we see as presenting is it helps you with your presentation skills. It also helps you with learning something and teaching it to some other people, which helps you retain that information. So yeah. Anyways, all right. Well, thanks again. So before Ben gets started, I wanted to kind of show. I've been taking a training on generative AI, and they have a. I'm talking about Google here. They have a nice repo that I wanted to share with you that you might find helpful. So let me share my screen and I'm going to show you. All right, you can see my screen. You can see the um, GitHub.
Yes.
Okay. So this GitHub repo and subfolder is from Google Cloud, um, and it basically has a bunch of code that talks about anything related to the AI offering. And you can look at this as it whatever you learn here. Yes, you will probably be using Google tools, but it's not any of these things can be translated into other companies, right? So for example, if you learn generative AI here, it's similar to, let's say you learn it, you go and use like OpenAI APIs. So it's a very rich repo. It's developed by people at Google and I think other people outside of Google, but mostly Google folks. So they you definitely would talk about best practice on how to use the tools and even best practice in general. So as you can see here, this is all about generative AI, right? So how to build a conversation AI. I think Ben talked about embeddings a couple of talks ago, if you remember, when we talk about things like vector databases and the vector space. Um, Gemini, which is the latest Google Chat GPT, if I can call it that way. Um, Language, which is their large language models, kind of like um, offering, and then these are kind of like, oh, and then vision right here, vision. Oh, it's an also speech. So the training that we went to, um, can you see the intro to Palm API? I want to make sure that I'm sharing the right screen. Can you see the Palm API? Hello, can you hear me?
Yes, we can hear you.
Oh, okay, I just want to make sure. Um, so Palm API is the Google's offering for their most of their AI models, and this is what you call a notebook. I suppose everybody here has heard of Jupyter notebooks, right? Or if you haven't heard of Jupyter notebooks, can you let me know so maybe I can explain what it is? Oh, well, I can just explain what it is. So basically, Jupyter Notebooks is a tool that where you can embed code and documentation, um, and it's mostly used by data scientists and machine learning engineers. So basically, as you can see, um, this is the code for the Jupyter Notebook, and you can embed documentation, right? So here, it talks about what are LLMs. It talks about Palm M, and then once you scroll down, you can see you can actually start running code, right? These are cells, and then you can run code directly with documentation attached to it. So, like I said, this notebook here is about how to use the Palm API um, um, AI model, and you have the different type of model like text Python, and they have different types of models available for you. And it explains how to access the API. It explains pretty much anything for if you're trying to learn the basics of Palm API, right? Then if you come to so this is the language. Then you have prompt. So like prompt design, which is kind of like how we go into ChatGPT and then we kind of like ask it questions. There are ways and best practices on how to do that, and whatever the best practice that you would even learn here would apply to ChatGPT. So it kind of talks about the different types of prompt design possible. So, for example, you see best practices. So you have to be concise, be specific, ask one task at a time. So those kind of like things that maybe would help you with uh, asking better questions to these AI models. Um, let's see. So yeah, you can take a look at this at your. Oh yeah, and it also talks about the different types of prompt, like zero shot, one shot, few shots. I won't get into these, but I'm kind of like showing to you that this repo it could be like really good if you especially wanting to be hands-on because you can run these cells and then it would actually like give you the output of the code here, right? Uh, let's see. Is there anything else that I wanted to show? So we have the prompt. Yeah. So like I said, we have speech as well, speech recognition, and then we have vision. Remember a couple of weeks ago we talked about Gradio, where you could build the tool that you could use to build um, chatbots. See, they have code for it here. Um, even things like LangChain. They also have code for LangChain. I believe that's here. Or what is LangChain? LangChain. I think it's orchestration. Yep. So LangChain, we talked about that as well. You can see it has documentation, awesome documentation for it. You can come and kind of read about. So it's a very good repo to kind of like go in and take a look at code snippets and basically learn as much as we can. Any questions on this at all? Oh, we have a quiet group today. Is Ben back?
Yep, I'm here. I'm ready.
Okay.
I'll let you finish and then I'll jump in.
I think I've finished what I wanted to kind of showcase. Or unless there are questions on this repo, I will share it right now. Um, Ben, have you seen this repo before?
The one you showed?
Mhm.
No.
Okay.
This is okay. So I'm ready. So let me share my screen over here. Let's see. Screen 2. 1 second. Okay. Okay, so can you guys see my screen?
Yes, it's a little small. If you want to expand, please.
Okay. Okay, how about now? Is it better?
I mean, we see a screen, but everything is. Oh,
Yeah,
okay.
I haven't typed anything yet, so I'm
Ah,
just showing you the screen.
No.
Okay, so like I'm not done setting up my slides, so I will share them later. But those are some of the points that I want to cover, you know, that I think are important in the process of building a chat app, right? So so let's start by I'm gonna do it in Python. So is everyone familiar with Python generators, or know what it is?
Maybe explain.
Okay, so let's see. So let's do like let's call this one a little generator. It's gonna be code heavy today, and so let me open this. Actually, I'm gonna initialize a new Python environment. So Chatbot mechanics. Open. Okay, so I'll leave this one blank for now. Okay, so choose project. Okay, so essentially, come on. Give it a second, guys. It's my ID is stuck a little bit. Oh, so okay. Okay, so I think one of the examples that come often for generators is essentially something like this. I can create a function, and usually a function will can return something, right? It can return like a value, like hello, right? But whenever we have something like this, the function itself, the execution of the function itself terminates right away, right? So for example, if this was a for loop, and then we go ahead and return I, we're not gonna see the first time I is returned, we're not gonna see the rest of the values. So Now, so if I run this one, do something. Wait for the then equals main, then equals main. What did I do here? Actually, I'll show it to you here. Let's take an existing app that I have that I can explain it to you better. So, okay. So if we look at this piece of code, right? In this code, pretty much, I'm retrieving some information from a URL, like a list of dog breeds, and then I iterate through it to return one breed at a time. And if I take let me start. So let me run this one. Okay, so if you see what's happening, we can see that we are receiving one dog breed at a time. And the reason we are receiving one, okay, I'll show you the structure of the code first. So this application is pretty much a small API. It's a small API that serves that retrieves that retrieves dog breeds, right? And instead of receiving the whole response all at once, through the use of Python generators, I'm able to send one breed at a time. So, for example, if I was to copy the whole URL itself, we can see that in the browser, all of the information comes at once. There's no delay, right? But instead, instead of instead of waiting for all of the information to be available before returning to the client, I can directly serve the information as I receive it, and the way to do that is by yielding, so that whenever I grab like the first item in the list, I don't wait for the rest of the items to be available. I can yield it, and then the client gets to receive it right away. That does it make any sense?
So you're saying that in that case, then you're gaining you're gaining speed essentially, right?
Yeah. So okay. So I have this small diagram here. So what I'm trying to explain is that, like usually when let's say whether you call a function or you call an API endpoint, you usually make the request to the server. the server will process it and then return the whole response all at once, right? And the case that I just showed, pretty much instead of waiting for the whole response to be ready, I can make a request to the server, and then as the server is processing, like, let's say, a list of items, like the list of dog breeds that we saw, it's gonna send back, one dog breed at a time. And pretty much to allow this to happen, we make use of Python generators. So here you will notice, by generators, I mean that we're using this particular keyword, yield. So instead of doing like return, like some dog breed, if I do that, if I was to do that, the for loop will just stop. Actually, let's see that right now. So if I was to do this instead and rerun, you can see that the fact that I've used return, we broke out of the for loop. This is what you see here. So it only had a chance to grab the very first item in the list, and since the whole list of dog breeds did not get a chance to accumulate in the response, I only retrieve the first one, just because I broke out of the loop because of that specific return keyword. And instead, if I put it back to the way it was, using yield and rerun the application, the yield never breaks out of the for loop. It's gonna allow the for loop to keep running until I tell it to exit. So if I try the same request again,
So
yeah, go ahead with your question.
yeah, so you said that it will keep looping until you tell it to exit, but I have a question in terms of, if the list has a finite number, then and you're looping through that list, what if the list finishes? Like, you're gonna have to get out of the loop, right? Or no?
Yes. So like I showed earlier, if I have a return, the first time, like, let's say this is the this thing here is basically this is basically how I'm fetching the list of dog breeds in this case, right? So the first iteration of the loop, I'm gonna get the very first dog breed, and if I return it, the fact that I'm using a return keyword inside the for loop makes the loop stop, right? But if instead I do yield, I can still the client can still get the data out of the loop, but the loop keeps going to grab the next item, and then the next item, and then the next item. And you can see that I have a conditional here, so that if the server from which the dog breeds are coming from has no response, then in that case,
Get out.
I'll return this part. So the breed will be none, will be null pretty much. And then I can just return the stop iteration.
Okay, got it. So there is a way to still get out of it, even with the yield. Okay.
Yeah. So this is part of the Python standard library. So here I have this example with dog breeds, but let me see. But it could have been like a list of numbers, or actually, let's see if we can do this one. Let me comment out this one. Let's see. Okay. But I mean, what I'm trying to say is that this could have been any list that we can process, whether it's a list of numbers, list of names, it doesn't matter. In Python, if you're using the yield keyword, it's gonna return the current value of the iteration and then keep going. But instead, if you use the return, it's gonna stop the loop. And then if you know explicitly that you don't have any more items to process, then you can just use the stop iteration. So, okay. So I'll show you more about how this is structured. Basically, what I'm trying to illustrate is this one, using actual data. So the way the application is structured is that we request this path, which is here, and this path is pretty much mapped to this endpoint over here, right? So when the endpoint starts to process, I create like a temporary queue, and then I tell it to go and fetch the dog breeds. And in the dog breeds function, that's when I make the HTTP request to some dog breed API. It's a free API used for testing. It's available to everyone. So this one gives me the dog breeds, and you can notice that the input of that function is the queue that I created here. And pretty much, I add each one of the dog breeds to the queue, and as soon as I insert a dog breed into the queue, let me see. So as soon as I insert a dog breed into the queue, like I have this other function here, which at the same time tries to pull items out of the queue. So on one side, this function puts items into the queue. And while this is happening, this other function here pulls items out of the queue. And it's possible because this function runs in the background, and then this one starts iterating to pull items out. Right? So on one side, it's as if you have two workers. On one side, one is busy adding items to the conveyor belt, if we take the analogy of a factory. And then on the other side, another worker grabs each item that comes down the conveyor belt, to send it to the client. So, and And basically, like you can see that this function is nested into this one. And the reason for that is because this function is pretty much the definition of a generator in Python. You know, so you can think of the generator as a value that can keep yielding more results, as you call it. You know, so let me pick. Let me make a small example. That way, just to clarify the concept. So if I'm let's see. So I can nest the function, and then I can yield a result, right? So
I have a quick question, if you don't mind me asking. So, does it mean that every time you retrieve a value, it's a new request?
Let me see here. No, it's not really a new request. So, okay. So let me put this one into a variable. So this function here is nested, and then I can reads. I can call it reads generator. Right. So you can think, okay, so basically the generator does, it's not really a new request per se. It's basically something, like you can think of it as an object that can produce values. But those values do not yet exist unless you decide to grab the next one. So
okay.
Behind the scenes, every time you call that, you call next. Every time you call next on the generator, it produces a new value. It produces the next value, I should say. And then if you call it again, it's going to produce yet another value. So if the generator was for like a list of numbers from 0 to 1, the first time it will generate 0. The next time you call next using that same generator, it will produce 1, and then 2, and so on until you run out. And when you run out, basically this value will be raised. You know, and that's like this value. It's a special value, like in the Python standard library, to indicate that there's nothing else after that. You know, so it's like a signal to indicate that, okay, the list has been completely consumed, and then it stops.
Okay, so let me try to understand. Let's suppose we have an endpoint, an API endpoint that kind of renders about 10 items, 10 things.
Right.
So when you make your request, will the generator grab all the 10 values and store them somewhere and then will display them one by one, or the generator will go every time and retrieve one value?
No, it doesn't. It doesn't. Okay, let me pick the next example so you can. It's gonna make more sense. So, okay. So I have a similar example with similar to the ones I showed with the dogs, but this time around, it's gonna use the OpenAPI, the OpenAI API. So if we look at the endpoint for that, I'll walk you through the endpoint real quick. So I'm sure you've had this experience, right? Let me open it. Let me open a new OpenAI chat so you can see what I'm talking about here. So if I ask like a random question, describe and right. So pay attention to this behavior by looking at the cursor. What's happening is that on the OpenAI side, they could have just waited for the whole paragraph to be ready and just send it back at once, right? This will be the regular case that we are all used to. But it turns out that they don't do that. They start sending us the text of the response right away and one word at a time.
Almost like streaming.
Yes.
Okay.
So the thing that helps us do streaming in Python is what's called a generator.
Okay, that makes sense. Yeah. All right.
Yeah, I can see that behavior, the behavior of waiting and outputting the text in some other LLMs. I've seen that. And I was wondering why it wasn't doing the same as ChatGPT, because you were just waiting and you don't know if it's actually doing something. Right? And then all of a sudden, all the text appears. Yeah.
Exactly. Because, I mean, even when we discuss, right, I cannot talk to you and tell all my tell you all my sentences just in one shot. I have to say it one word at a time for it to be regular conversation. And in the case of a chat, that's the exact behavior that we are shooting for. Instead of sending a whole block of text, that's not really like conversational, right? It almost looks like a search result from Google, right? But if we're talking about having a chat, like having a discussion, it makes more sense to stream. And the way to stream in Python in particular is by leveraging generators.
Right. Okay.
Okay, thanks. That's a great explanation. Thanks.
Yeah. Okay, so let's look at this example here, so we can see it in action. In this particular case, okay, how to walk it through. Yeah,
I don't know if it's me or not, but can you maybe expand a little bit more? I don't know if it's small for everybody else too, but maybe a couple of zoom in.
Let's see. Can I zoom here? Zoom.
If it's
Okay, increase. Increase. Is it better?
I think it's better. Yeah.
Okay. So here I have a similar setup as before. It's basically a small, a small web application, but what we are paying attention to right now is this endpoint, and you can see, as the name implies, it's gonna give a streaming response, and so the request comes in, I instantiate a queue in memory, and then I'll launch the first process, which is to go ahead and fetch the response from OpenAI, right? So I have this helper function here. Is everyone familiar with async await for Python? No?
Yeah, I've heard of it. Yep.
Okay, so simply, I won't bother you too much with that, but you can think of it as like a way to do a lot of work in a concurrent manner. You know, like walking and chewing gum at the same time type of stuff. You know, by default, Python can only do one thing at a time, meaning that if you're chewing gum, you cannot walk, or if you walk, you cannot chew gum. But with async await, you can do both or more, right? So this helper function here basically leverages async await, which is built into Python again, to be able to execute the function in the background, right? And while this is happening, okay, so while this is happening, like running the query against OpenAI in the background, while this is happening, I create a generator, right? And again, the first background task takes in as input this queue that I've created, because when it's doing its work in the background, it's gonna start to add each words of the response, like we saw in this UI. It's gonna add each word of the response into the queue, and while it's busy doing that, this generator over here is gonna read item off of the queue. You know, so this function will add words one word at a time. This generator will pull out one word at a time. Right? And again, since I can pull out one word at a time, I can use an iterator to basically help me pull out each word that I put into the variable called response. And I check whether or not the response is null. If it's not null, then I yield, right? So when I yield, it's a way to return the value from the generator without stopping the for loop. You know, so I keep doing that until there's no more response, in which case I return this signal to indicate to the client that there's no more coming. And then at that point, you know, the client it knows that it's done. So, like, any question on that?
So far, so good.
Okay, so let me run it so you can see it in action. So this time, so if I curl it, you can see the response streaming from OpenAI. Right, so it's gonna do that until it runs out. You know, and I'm printing the same thing here into the logs for the server. Okay, so we can see that it's done, right? And it says done answering senior, right? So basically, this mimics exactly what we saw over here, right? So to sum up what we just saw, we saw the first case of obtaining an answer in one shot, like this one. So if I can, oh, sorry. To copy. So if I do this, I get everything in one shot, right? That's the first case. The client makes a request to the server. The server processes the request. And while this is happening, the client is just waiting. The client is just waiting. And then whenever the server is done processing, it just sends the response back in one shot. This is exactly what we saw. And the second case is this one. The client again makes the request. And as soon as the server starts processing the request, in the case of like, if the server is processing a list, as soon as the first item is ready, it starts sending it back to the client, right? So the client doesn't have to wait. The client starts getting an answer right away, right? So for this to actually be possible in the case of HTTP, notice this part over here, right? The way that the client knows that there's more that there's more items coming from the server, it's simply because the server, when answering, will tag each item of the response with this. So that's how the client knows that it's not just one answer coming, it's actually a streaming answer. So an answer that has multiple parts.
And that way the client does not disconnect or something like that.
Yes, that way the client doesn't disconnect.
Okay.
And does this make sense?
Mm-hmm.
Yeah, totally. Yeah.
Okay. So let's look at it in the browser. This one. So I'll go back to the previous example, which is this one. So it's the same application that I showed earlier with dogs. And let's refresh. Okay, so I don't know if you can see this on the left side. The dog breeds are pretty much coming one at a time. And while this is happening, as an indication that there's more, there are more breeds coming from the server, I'm displaying this, right? But notice how at some point it's gonna change to say that there's no more dogs, and then it's gonna restart. So give it a second. So pay attention to this part. Okay, did you see this? It flashed very quickly and then started over. Were you able to see it, everyone?
And for me, it's kind of cut off on the left side a little bit.
Oh, right. Okay, let me resize this a little bit. I haven't added any CSS, so it's kind of.
Oh, I see. Oh, I thought it was more on the left.
I wasn't trying to like spend all the time.
Okay.
Yeah. So look at it again. When it gets to the last, it's in alphabetical order. So when it reaches to the very last one, this part is gonna flash. So pay attention. Okay, so we see no more dogs, right? And then eventually another request goes out, and then it starts over, and now it says more dogs. right? So I'll show you how it works. So let's look at the HTTP requests. So this is my Chrome developer tools, and then we can see each part of the answer coming from the server on this tab. You see how it says event stream, and then if we look at the headers and we look at the response, we can see that the response has been tagged with this specific header that says text/event stream, and that's how the client knows that more items are coming. And if we look at this one, click here, scroll up. Okay, so we can see that I'm printing the logs while the dog breeds are happening, right? But from time to time, we can see this log over here. This log only happens when the server is done sending all of the responses, so we see another set of responses, and so we see another one, and then we're gonna see it flash again. So we see it's done sending the response, and then another sequence starts. So one thing, the fact that it restarts the response, I mean the fact that it starts another request over and over again, it has to do with how I've configured the page, right? So the page that you see here is set up over here, and I can quickly walk you through it. I've used a small library, JavaScript library called HTMX, but that's not important. It can be written any other way. And basically what's important is that the page itself knows about the endpoint that can stream the responses, right? And then we can see two interesting things over here. We can see this part that says no más. I think no más is Spanish for like no more, right? And then we see dog breed. So if we look at here, the part that corresponds to no más is specified on top, and then the part that specifies the dog breed is below. Basically, this is a way to tell. This is the way that we can pass the responses that are coming from the server, and I'll show you those responses. So if I switch back to the Python code, and we look at and if we look at the dog generator, right, the one that yields, we can see those things over here. So whenever we serve a response of this type of text/event stream in HTTP, we can enhance the message. We can enhance the payload. Instead of just sending a plain string, we can give it more structure, right? So one way that we can do that, this varies. It depends on the clients that you are implementing. So this part is not really part of the HTTP spec. It's something like a convention. That's only a convention within the context of my app. Since I've used this specific JavaScript library, this specific JavaScript library understands this structure. If I was using a different one, I will have structured it in a slightly different way. So what is that structure? The first part indicates what type of message the server is sending to the client. So the type of message what I mean is what type of event. So on this line, I'm sending the dog breed no mass event. And this one will be passed on the client and displayed here. In the second case, I'm sending an event called dog breed. So on the client, it's going to be displayed here. That's the reason why when we were observing the behavior earlier, we could see the different dog breeds, showing up one after the other in this section. And then this one will only flash like a couple of times. And to understand why, we just have to look at the structure of that generator. Basically, whenever we run out of items, we specifically return this event that has this information indicating that there's no more dogs in the list, dog breeds in the list, right? And in the case that we do have more dogs coming, coming next in the list, it displays this part instead, that there's more coming, so that's why when it's serving, we can see that there's more dogs coming or no more dogs coming, and then this part is solely responsible for displaying the individual dog breeds. Okay. Any question on that?
No, I think it's pretty clear.
It's pretty clear? Okay. So I'll show you a variation of the same thing, but this time using the OpenAI app. So where is it? So it's this one. So I can run it. So if we look at the generator for this one, it's similar, but instead of dog, we're just dealing with responses. Same structure, right? So I'll refresh. We can see the same thing happening. So when it's done answering, it says it, done answering senior. And then the request kicks back in. Now it says thinking. Then done, and then it's gonna restart. So let me stop this, and then I'm gonna switch to the ChatGPT UI. I can prompt it for something else so that we can observe the behavior. Okay. Okay, so you will notice, I think, this button, right now it shows up as a stop button. Okay, you notice how it changed? When it was still feeding us back the responses, this button showed up as a stop button, right? And then as soon as there were no more responses, it switched back to being a send button. The reason for it is, I'm not saying that they have the same implementation as what I just showed, but they have a mechanism to detect whether or not there's still more answers coming, or if all of the answers, the whole answer has been sent to the client. You know, because they also use event sourcing to stream the response, right? And then each part of the response is also tagged, you know, and that's how they are able to tell whether there's more to display. And then if there's more to display, they turn that button into a stop button as a convenience. And then when there's no more to send, it switches back to being a send button so that the user can prompt for more, for something else. Any question on that? No? Okay. So a quick recap. ChatGPT is an API, right? By default, the SDK that they provide, and as well as a lot of the examples that are available on the internet or in documentation, it's usually for this scenario over here, which is a simple request and response. Right? Most of the examples you will find online are for this use case. But what they provide us through the chat interface actually uses the streaming scenario. Right? So let's look at let's look at the actual request to ChatGPT in the case of streaming. Let's see, run OpenAI. Okay. So what do we see here? Actually, let me show you the synchronous API first. So I have another application called CLI. Okay. Actually, let me run this one. Terminal CLI. Okay, I can log in because I've used it before. I've tested it before. So this is the username that I picked. Then I enter the password. And then I can just ask it, what did we discuss last night? Okay, so I added a bunch of logging so that we can see what it does. So let's see. Okay, so this is the response. And tell me the results of 1 plus 1. Okay, so 1 plus 1 is, okay. So what's happening here? Let's look at the implementation. I can quit. Okay, so you can see that I have reinstalled the OpenAI SDK, the Python SDK, and where is it? I lost my line. Okay, so through the Python SDK, like after importing OpenAI, I can instantiate this object called OpenAI, right? and then I'll tell it that I want to do the chat completions, and then I can pass it the prompt, right? So notice that there's no async await, there's no generators here. So this is a concrete example of the simple request and response case, meaning that it's gonna process the prompt on the server side, and then whenever it's ready, it just sends the response, the whole response in one shot, right? And then I can take that response and display it. And if we look at the streaming example, we can see that this time the API is, the use of the API is slightly different. They have an asynchronous version of the client, like from the SDK, which is called async OpenAI. And then I can do the same chat completion and pass it the prompt. But this time around, I have to wait for the response, you know, because it happens asynchronously. And because it happens asynchronously, you know, like I can mark the client as streaming, you know, so that's how OpenAI will understand that it shouldn't wait for the whole response to be available and then send it in one shot. Instead, it's gonna send me chunks of the response, you know, like a chunk at the time, right? So it's not, they hide it in the way that they wrote their code, but this chunk is basically a Python list. I mean, it behaves as a Python list, but behind the scenes, it's really a generator. And it's a generator for the reason that not all of the response is available from the start. You know, so the behavior is similar to what I was showing earlier. One process is running in the background, fetching the rest of the response. And the other process is this part that pulls items from the response as soon as they are available. So in a way, this chunks object behaves like a queue. On one side, one worker is putting items in, and then on the other side, another worker grabs the items for further processing. Any question on that? No?
No, I think it's pretty clear.
Okay. So let's see. So let me restart this. Okay. So we just learned about the behavior for having one-shot responses or streaming responses, but these concepts are part of like constructing a whole chatbot, but there are still Lego pieces missing. Well, one important piece that's missing has to do with the chat history. So, for example, if I switch back here, I prompted in this new chat, I prompted ChatGPT twice, but if I refresh the page, what do I see? I see that my previous requests and responses from ChatGPT are still available. They didn't just vanish. And they didn't vanish because on the OpenAI side, they stored our interaction into a database. You know, so on the left side, you can see other conversations I've had with the OpenAPI, and it's still around. Some of them date from last year, Some of them might be even like older, right? So let's see how this can be done. So if I rerun this one, and then I log in. Let's see. Okay, so what do you see here? I asked it, what was my last question? And then it said it back to me. Tell me the result of 1 plus 1, right? So let me show you how this one works. So let's switch to CLI app. Then I can okay. So I just showed you this part, which is, oh, sorry. Yeah, I just showed you this part. This is the part where the ChatGPT model is being prompted, and then it returns a response. But we can see something here. We have chat history. So that chat history is actually added to is actually combined with the prompt, and then the whole thing is passed to ChatGPT for processing. So in that manner, ChatGPT will have the context of the previous exchanges in addition to the new request. Right? So if we look at where this chat history is coming from, we have this. So this is a helper function that basically retrieves the previous exchanges into this format, right? So this part here is the sender, and then the actual message. So let's look at the structure of the message. So the message is nothing but a string. It also has a timestamp so that we have the precise time for when the interaction happened. And then we have sender. And also we have the chat room. The chat room can be something like this, like on the left side. And then we have an ID. The ID, it's an implementation detail having to do with the fact that I'm using a SQL database to store the exchanges. Right? So this is the SQL database that I use. And then you can even look at it. It's a file database. I'm using SQLite. So if I come here and look at the message history, we can easily recognize the chat room name. The chat room name, I just did it simply by using the currently logged in user as the chat room name, right? And to make a distinction between the prompt and the response, the sender is added accordingly. So if it's a prompt from my side, it will be tagged as you, like meaning me, the current user. Whenever I get an answer from OpenAI, the message will be tagged as GPT-4 to indicate what type of model I'm using on the OpenAI side. And then we have the actual message for myself, the current user, or the model. And then we also have the timestamp. right? So let's see. So let's switch to this one. Let's say message. So there's another helper function, which role is to persist the new, like each new message, whether it's coming from me or if it's an answer from the model, right? So all it does is to collect an instance of the chat room, which will be the username that I've used. And then the sender will be either you, meaning the current user, or the model, which can be like that can be GPT-4, and then the actual message, right? So a new instance is created and then added, and then committed to the database. So this is the entry point that I just showed that can combine the chat history together with the prompt, send it to OpenAI. And then if I scroll down, this is the one level up that makes use of both the function to collect the chat history and also collect the response by passing the chat history as the context, with the current user inputs, which is tagged as you. And then after the exchange is made, after the response is collected, then the message is persisted. So my prompt will be persisted into the messages table, by setting the sender as you, meaning the current user, and then also persisting the response from ChatGPT, which will be marked with sender equals GPT-4, right? And then this one runs into a loop. So the main function is pretty simple. As soon as the CLI application starts, it's going to check whether or not a username is available. If it's not, it's going to propose to either register or log in. So in the case of the registration, it basically collects the username, and then it persists that into the user table, like that. There's only one user at the moment. And for the login, it's similar, except that it's gonna grab two values. The first one will be the username. The second part will be the password. And the reason it's not using input is for just hiding the actual text of the password, because it's sensitive information, right? And then those are the details of how the user will be verified, pretty much. Yeah. Any question on that? No? Okay, so let's look at something that looks more pretty. Let's take a look at, let's do the tape here. Let's take a look at this one. Okay, so what's happening here? I'll show you, I'll quickly show you this part. So you can recognize that in this part, I'm using the asynchronous client for ChatGPT, hinting at the fact that we're gonna collect the streaming response, right? And I'm now using a different library, which is pretty popular right now for, in the Python ecosystem, called Fast API. Some people use it for serving models, others for building web applications, and so on and so on. And then the third interesting library in use here, apart from OpenAI, is this one, Fast UI. So I can show you what Fast UI is, what it does. Okay, so Fast UI is basically it's a very like new library. It's by the same author as it's by the same author of Pydantic, this Python library. But it's a Python library that helps to give more structure to Python objects, right? So it helps with by editing code with auto completions and things like that. It also helps for validating inputs to make sure that the data we want to process is correct, right? And it happens to be used. It happens to be one of the building blocks of the Fast API library that I mentioned earlier, which is this one. You know, that's the one I mentioned that is used for serving models and building web applications and so on and so on. Right. So the author of Pydantic, you know, after he came up with Pydantic, inspired another author, the one of like Fast API, and then later on, since he has good knowledge of the very interesting use cases of the Fast API library, he recently came up with Fast UI. So most of the people interested in Python and data science or machine learning typically are not coming from the web development background. You know, there's a lot of people in the data science industry that have other backgrounds other than like software engineering. So for them, it's a problem to have to like pick up web development as part of doing their work. You know, so for that reason, the Fast UI library comes with pre-built UI components that can be leveraged all directly from Python itself, you know, without the need of writing a single line of JavaScript, right? So that's what I'm going to show you here. So apart from this function that does the processing like we saw earlier, we can see this. So whenever we come to the home page, using the Fast UI library, we can start to structure a page, right? So we can give it a title like called Chat App, you know, and then we can start writing some text onto the page, right? And in this case, this specific file, like I rebuilt the demo of the streaming response from OpenAI, but this time using this library. So I can show you what it looks like. So notice there's no JavaScript whatsoever written in the project. Not even HTML. Basically, this file is standalone. Right? So as long as you have the libraries instead, if you just run that single file, nothing else, you will get the UI that's I can show you right now. So let's close this. So that was the old implementation I showed you earlier. So if I refresh, now we see this. And doesn't that look better?
Yes, it does.
Yeah, no, definitely.
Without writing any JavaScript, right?
Wow.
So if I click this, Look at this.
Wow, that's neat.
Now we can see colors. This was the actual, all this time we're seeing this ugly response. This was what ChatGPT was trying to convey to us. But we had a bad client, so it was hard to read, right? So let's go into details of how this one works. So let's scroll back up. Okay, so I mentioned that Fast UI comes with pre-built UI components, right? So they all come from the components module of Fast UI, right? So I just give it an alias of called C, so that it's shorter to write. And then in the home page, I can just do C that, and then I have auto completion. Auto completion with like some nice types. I can also over and see the documentation. If I have a paragraph, same thing. Same thing. The reason why this is possible is because Fast UI itself has been implemented on top of Pydantic. And Pydantic, like we saw earlier, helps to provide more metadata to the Python code, so that not only it's helpful for auto completion in the IDE, it can also catch a lot of bugs. Like for example, if I do this, I'll do this and then try to build the page, we should see an error, right? And what does the error say? So if we look at the details of the error, it says what? It says that that function takes at least one positional argument, but two were given, right? So why is that? Let's see. Let's go to the function itself. Okay. So that positional argument it's referring to is this one. It has this type. So we can see a bunch of stuff with Pydantic. We can drill down into the how it's implemented. But basically, what it's complaining about is that the API wants us to use it by passing a keyword parameter, specifically text. That's what it's expecting, right? And if we don't put it where it expects it, it starts complaining. And as soon as I save, you'll see that the server restarts right away. So I don't have to keep restarting the same app. It figures out that the code has changed and then does an auto reload. So all I have to do is to come back to the page and refresh the page, and then it works again. Yeah. Any question on that?
No, I think it's pretty clear.
Okay. So yes. Okay. So that's not 100% of what I wanted to show you, but I ran out of time preparing the demo for the full chat application using Fast UI. So what I'm proposing then is to maybe continue the discussion for the rest of the time that we have. And then for the next meeting, I'm gonna build a full-fledged application using all of the concepts that we discussed today, and also using the Fast UI library. And then I will share the code with you guys. That way you can play around with it at home and build your own stuff. Yeah. So we can have a discussion now about anything, that or anything.
My question is more about, I know it's not totally related, but the concept of generator you were using, and is that the same? Is that the same concept used to generate images as well? Because I noticed for the images, it's not like one shot. It's like one layer after another layer. Is that the same concept?
Yep, same concept. Let's see if we can generate one over here. Give me an illustration of. I'll just make up something to see if it's good. If give me an illustration of a Python generator, because why not? Let's see what.
Yeah, I'm curious about that. Let's see.
Okay. So that's interesting. What does it say? It's an illustration of the concept of a Python generator. The image shows a playful cartoonish Python symbolizing a generator yielding. Oh, that's actually cool. Okay, that's actually a good image because the Python is holding, I don't know what kind of Python has hands, but anyway, the Python is holding a scroll, right? So for the text in the scroll to reveal itself, it has to be unrolled, right?
Oh, okay.
Right. So in a way, that shows what the generator does. You know, it's not possible to show. I mean, to see the content of the text of the scroll all at once. We have to reveal it progressively by pulling against it.
Okay, yeah, that makes sense.
So we might read like one line at a time until it's fully unrolled. You know.
Yeah.
Let me see if it can come up with a good example of good example of Python generators. Let's see if it can explain it better than I did.
Yeah, but you did a very good job explaining. So for me, it's pretty clear.
Okay, so it gave a couple of examples. So yeah, because I mean, sometimes it's I find it a bit hard to explain. The reason for that is, if we look at this, then it's easy to just think about like a while loop or for loop. You know, so I mean, people that are not too familiar with generators, you know, will not pay attention to the fact that instead of this function returning a list, it doesn't. You know, because usually for loops are for lists, right? Or collections, right? But here, there's no return value, so there's no list. You know, so basically this while loop over here is counting up to the maximum value. And that maximum value is 5, right? So if this was stored into a variable, and then we will call the next function on it, the first time we will get 1. And that's it. And then if we call it another time, it's gonna yield 2. You know, basically the current count lives inside the generator. You know, it's stateful in a way. You know, and then when we call it again, it just increases the internal state of the generator. and so on and so on until it produces all the values. You know.
Okay.
Yeah. So this one, actually, I will share with, like, I have to find the link, but there's a very good presentation about generators. Like, I think it was at the PyCon US. I forgot which year. I don't know I think it was 2023 or 2022. I watched a pretty interesting presentation about generators. I'll share that in the chat. So I think the guy did a much better job. I think it's like an hour talk, and he shows like a whole bunch of like use cases for generators. Yeah. Yeah. So this is a very powerful feature for the case of, especially in the case of web applications, because if we take the case of returning full answers all at once, full answers take more memory than streaming answers, right? Like basically, if a full answer is like 5 kilobits and a streaming answer, like each piece is like 1 kilobit, you know, we can store more streaming answers in memory for a server than full answers. You know, so if, for example, a company doesn't want to spend too much money, it's cheaper for them to serve streaming answers to their customers, like in the case of OpenAI, right? Otherwise, the accumulation of all of the customers using that server all at the same time will make the server run out of memory. You know, so for them it will be it will be a big cost, right? Because if they don't want the server to crash and disrupt the customer experience, they're gonna have to purchase larger and larger machines. Whereas if they stream all of their answers, you know, the accumulation of like fractions of answers for all of their customers is much, much, much cheaper. You know, even when they happen all at the same time. So, you know.
Yeah, that's really interesting for sure.
Yeah. I was gonna come up with a very bad analogy, but I don't know if I should. Yeah, let's say you're thirsty.
Let's hear it.
Yeah, let's say you're thirsty, right? You're not gonna drink a whole 1 liter bottle all at once, right? You can't swallow that much water like all at once. So you have to take 1 cup at a time, and not even 1 cup at a time, 1 sip at a time. You know, eventually you can run through the whole bottle, but surely enough, you cannot just swallow a liter of water in one go, because that's gonna be damaging for you. You know,
Yeah.
it's the same idea.
Okay. Yeah.
Customers request coming, they cannot just grab the whole thing and send it. Like the servers will crash and they will lose a lot of money. But they can spoon feed it back to the customers, right? And that flow, that streaming answer, right? The fact that it happens right away when we prompt like ChatGPT, for us, it makes for a good experience. You know, because if the whole answer is like 5 paragraphs, us humans cannot read 5 paragraphs all at once anyway. But we can definitely read 1 word at a time. You know?
Yeah, definitely.
Yeah. Yeah. And any other questions, thoughts?
For me, it's more like an information. I know you were working on the website where I could find the previous sessions. So any update on that?
Yes. It's not complete yet, but it's on its way. So I think it's next, this one. So you can tell me about my designer skills.
I mean, I already say I like it.
Okay, so this is the new version I'm working on. So it has dark mode and everything. And it has an articles page. I think I'll publish some of the ones. Oh, it looks terrible in here. Hold on, let me open it in Chrome. Let me open it in Chrome.
Safari, man.
It looks good. I mean, for me, it's more about the videos. I want to be able to go in.
So there's that. And then we can, let's see, which one should we see? Let's open this one, for example. So we have like the bullet points about that topic we covered. We have illustrations, we have code, and so on and so on. I also have the events. Right, so some of the tags that we use on the Meetup platform are added here. Right, and then we can see some of the events, like today's event. Some of the past ones. And let me see, what did I do? I also have the registration and signing in, but I'm not done implementing it. It works. People can register, but even when they log in, they're not gonna see anything different currently. It's coming. I think I'm gonna finish that feature when we have a dedicated page for video. The videos I started to edit, videos from previous sessions. I think I published one on the internet.
Yeah, you wanna show the one that you uploaded?
Okay. YouTube, okay.
Let's open. I have this thing so that I don't browse YouTube too much. I have a timer actually for a bunch of apps that are big distractions. I think it's thinking like whether it should let me see it. Oh, come on, let me refresh. Come on.
Yeah,
Ignore limits. Okay, finally. Okay, so let me see. So this is the channel. Yeah, my editing sucks. I have things like this.
Tech.
Yeah, so je puisse utiliser la commande SSH. Yes, I was speaking in French at that point.
oh yeah, this one is. What day was this? Oh, it was May.
Yeah. So this one was about DevOps, like to do it manually, and yeah. So basically, what we're doing for video, we're gonna have two types of videos, like the recorded sessions for the meetup. I'll publish them on YouTube directly, and then there's also another type of videos that I started producing. Let me see, where's my... Okay, like these ones.
I'm having a hard time finding this specific link. When I type OGTech, okay, I think I just found it. It's fine. Thanks.
You got it?
Yeah, I think I got it.
I can put it in.
Yeah, if we could put it in the chat, that would be helpful.
Yeah. Put it in the chat. I'll put it on WhatsApp also.
Yeah. Okay. Right. Yeah. That's good.
Oh, I can see the WhatsApp window right now, but anyway, I'll post it after the meeting. And I forgot to mention, we also finally created a Discord, but apart from Aziz, no one joined yet, because obviously we haven't announced it, but we now have a Discord as well. So this is gonna be an option to like keep in touch and do different things.
Mhm.
So what I was showing you is, where's my folder? Okay, so I started doing some recordings like this. These ones are gonna be better quality, or at least visual quality for following tutorials like step by step. Right. So these ones, like since I'm like we intend to do them like chunks at the time, like I can publish them directly on the website, so that they're gonna live side by side with the corresponding article, so that whoever wants to follow along, it will be easy to have the video right there available, as well as the text and the code. Whereas YouTube, there's no good way to like put everything side by side. So,
Okay.
yeah, so this is coming. Like, so, yeah. Any other question, thoughts? Aziz, anything?
No. Very interesting talk today. Nothing for today, no.
Yeah. Yeah. So for the next meeting, I'll work on this version of the on this version of the chat using these libraries, so that we're gonna have persistence for the chat, to pass it as context to ChatGPT so that it can give us better answers. And also, it's gonna give you a chance to, and also myself, a chance to dig deeper into the fast UI library, because it's a big time saver. Like, it gave me some ideas on like stuff to build, because so sometimes building websites can be annoying, like writing all those HTML tags, making sure the dimensions are correct, and so on and so on. Whereas if somebody did it, at least it removes some of the pain, so we can quickly have so that we can quickly have an initial version of the thing we want to build, and then tweak it from there. So it's gonna help me and also you dig into deeper for the fast UI library, to quickly put stuff together and then back it up with some model and just play around. So yeah, so that's what I'm gonna focus on for the next time, which is gonna be part 2 of this. So yeah. Also join the Discord. The link is here.
Okay. Yep. That's it.
So yeah, and also one thing, this website also has support for French and English. So if you are in a region that speaks French, it should show up in French. Actually, let me see if I can do that. So I haven't added the button yet to switch languages, but I can do it manually. Okay, so we say now it's in French. So, yeah. Yeah, during implementation, that's actually a big time sink as well, because I have to come up with like the text for English and then think of the translation. And then it turns out that French is more verbose than English. So sometimes the text can be very long. So I have to think about how to rephrase it to make it shorter. Like, it's really annoying.
Yeah, French is very verbose for sure. Yeah.
Yeah. So, yeah.
All right. So anything else at all?
Just thank you again once more for taking the time to share your knowledge with us.
Yeah, thanks very much. That's my pleasure. And thanks for assisting to the meeting.
Yeah, thanks.
Yep, yep.
Thank you, guys. Thank you.
Thanks. Have a good weekend.
Thank you.
Thanks, everyone.
Bye.
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 All right.